Hello, everyone. So these are the solutions to the practice quiz for Unit 4. So 1 and 2 involve answering questions about a cosine and sine function. So the amplitude is always the value that's multiplied in front, the absolute value of the value that's multiplied in front. So if that was a -4, you would make it +4. The period is 2 pi over the absolute value of b, which is 2. So the period is pi. So this function, 2 sine x plus 3, find the minimum, find the maximum. So you are taking the midline value, which is the k value, which is the value added on the end, and you're subtracting the amplitude for the minimum, so that lowers you to the lowest point. And you're adding the amplitude for the maximum. So these are y values. And there's a page in your notes that demonstrates that very well. I think it's the second page. All right, so match these up, and I'm going to tell you that you probably do not need to do full-blown A, B, H, and K calculations. Just use a little common sense. So in general, sine graphs tend to go through the origin. So here and here are going to be sine graphs. And cosine graphs tend to go through the y-axis, not through 0, 0, though not always. And then take a look at your amplitude. So this here is going to be a cosine graph with an amplitude of 3. Or a sine graph possibly with an amplitude of 3. But notice the 1/2 here. So 1/2 as a b value is going to stretch out the graph quite a bit. So this graph is stretched out more, this graph is stretched out more. So those are going to have the 0.5s, and then the two graphs with the b value of 2 are going to be compressed more. So these are going to have b values of 2. That you can just reason out as you're doing this. And then take a look at the amplitude. So this is going to be cosine graph, b value is 1/2. Or let's start up here, this first one. So b value is 2. This is going to be a cosine graph with an amplitude of 3. Well, that's number 4. This is going to be another cosine graph, not going through the origin. B value is 1/2. Again, because it's more stretched out, so I can reason. It's a reasoning process. You could do the A, B, H, K calculations also, like I showed you. But you can also use this reasoning process. So the one with the cosine that has a b value of 1/2 and an amplitude of 2 is this one. This third graph, b is 2. It's going to be a sine graph, and the amplitude is 2. So that's this top one. And then that just leaves the last one. So a b value of 1/2 and an amplitude of 3. So it's a little bit of logical reasoning, which I also like sometimes in a quiz environment rather than just compute, compute, compute. Okay, 7. So this is all about looking up the trig identities and using a little bit of flipping and multiplying. So cotangent is cosine over sine, and then the cosecant is 1 over sine. And then you're going to flip and multiply this. Lots of fractions divided by fractions in this unit. And I've showed you why that's true, because you're trying to create a 1 in the bottom, so you're going to multiply by sine theta over 1 on the top and bottom of the fraction. So that's why you flip and multiply. So this is cosine of theta, which is b. Okay, same idea here. You're going to have a fraction over a fraction. So cosecant is 1 over sine. Divide that by 1 over cosine. So we're going to take the top and multiply by the reciprocal of the bottom, theta over 1. So this is cosine of theta over sine of theta. And that equals cotangent if you look it up. So you're constantly trying to get everything in terms of sine and cosine, and then at the end, is there something simpler? So this is in terms of sine and cosine. Is there something simpler that I can look to? So the first step is to get everything in terms of sine and cosine. Look those identities up. Same thing here, Pythagorean identities. The top is 1. And then tangent squared plus 1 is secant squared. So this is equal to cosine squared. So the reciprocal identity squared equal the other side squared also. So 1 over secant is cosine, therefore 1 over secant squared is cosine squared. Not too hard to do. You're just substituting in things, and 10 and 11 are probably even easier. So this is already in terms of sine. Put it over 1, and then this is cosine over sine. Yes, it's true that cotangent is 1 over tangent, but you don't use that very often. You need to remember it, but you don't use it very often. So that proves it. This is 1 right here, sine squared plus cosine. Cotangent squared is cosecant squared. That's an identity. And there it is. So it's a simple substitution. Cancel things out when you can, and you'll have it. Now, trig identities get a lot harder than that, but we're just going to deal with ones that are very basic. Taking us to problem 12. So again, you need to get the min and the max correct on this. If you don't, well, the whole thing's going to be wrong. So 11, negative 15, and 19, 12. So you start with 0, beginning of the day. So 11 hours, it's 15 feet below normal. And then at 7 p.m., that's 12 hours, add 12 for military time. You're thinking that way, 1912. Calculate A, B, C, and D. So when you do this, this will give you 13.5. So 27 over 2. When you do B, you're going to get pi over 19 minus 11, which is 8. And then here, you're going to have 30 over 2, which is 15. And then here, you're going to have negative 3 over 2, which is negative 1.5. Then you're going to take all of that and put it into an equation that you're going to enter actually on your main screen. Plus negative 1.5. So that's quite a bit of entering to do there. And actually you need, when you enter it in, we're going to need a set of parentheses around the pi over 8 there. When x is 17, find y. So 5 o'clock in the afternoon is 17 hours gone by during the day. And so you're simply going to make sure you're in radians mode. Why? Because this is in radians, the b value. So I've messed that up a couple times. You need to make sure, that as you put things, if you're putting in, you could probably convert pi over 8 to degrees and be in degree mode, but I'm just going to leave it alone as it is. So x is 17 minus 15. Okay, another set of parentheses plus negative 1.5. Okay, so 8.0 feet. So approximately 8 feet. And then what's the period? So this is the other way of calculating the period. It's 2 times the absolute value of x max minus the x min. I'll write that down. I haven't said it very much, but 19 minus 11, absolute value, which is 2 times 8, which is 16 hours. Okay, and there's the practice quiz for our 4th unit. Just one more unit to go.